Hello and welcome to the next in the series of programming on the Commodore 64 in assembly video. Today we will be looking at sprite animation using interrupts. Okay, so if you've watched the previous videos, video 2 we explored how to design sprites and display them on the screen. Video 3 we discussed and did an example of how to use interrupts to run code on the raster bar interrupt. Okay, so what we're going to do is we're going to combine those two techniques and do some sprite animation using interrupts. Now, the reason we use the interrupt to animate our sprite is because we can keep the code for the animation separate from the game logic. So the interrupts will worry about what the sprite looks like based on some values, and the game logic can then carry on. Okay, so the first thing we will do is we will hop over onto Sprite Mate and start designing some sprite frames. Okay, so here we are with Sprite Mate. As you can see, I've designed what looks like a PacMan sprite on here. It's just a very basic one for this example. This is a high-res single colour sprite. So this is PacMan with his mouth shut. Okay, so what I've done, I've labelled this sprite 0, R and 0. So R is the direction he's facing and 0 is the frame and 0 there is the sprite number. Okay, so let's do some animation frames. So Sprite Mate's got some very good tools built in for this. So we select the sprite here and we will do duplicate sprite. So we'll select this one, so we'll change the name of this to R1. And for this we will start using the erase tool. Okay, and we can start doing his mouth starting to open. Like so. See, I'll just erase those there. So his mouth has started to open there. And then what we'll do, bear in mind this is very basic. Let's duplicate that again. Okay, and we will do that as frame 2, and then we'll open his mouth fully. Like so. Okay, so now we've got 3 frames here. So the way our animation will work, it will show this frame, then this frame, then this frame, then back to this one, and then back to that one. Okay, so one more thing we can do is let's do him facing left as well. So again, using Sprite Mate, we've got some excellent tools here. So we will duplicate this one and let's label that appropriately. Then this one, we'll duplicate that, label that appropriately, and then this one we will duplicate, label that appropriately. Okay, but these are exactly the same, so it's not doing anything. So what we will do is we will click this frame and we'll use this tool up here, which is flip horizontal. Now that's flipped horizontally, so he's now facing left, and we'll just do the same with the others. Like so. So there we've got our animation frames for PacMan facing left and animation frames for him facing right. I'm not going to bother doing up and down for now. For this example, we'll just stick with the left and right. Okay, so now we want to export this, and it's a simple case of hitting the save button. I'll save the Sprite Mate files as well in case we need to go back and edit them or add some more. I'll do that off camera, but for now we will just save as kick assembly hex. That will download a file there, and we can paste that into our code shortly. Okay, so back to our code. Okay, so for this video I will probably copy some code from one of the previous videos. So the first thing we'll do is let's copy the code from the video 2 that just displays the sprite on the screen, and I know that was a high res sprite, which was sprite 0 and sprite 1, and we overlaid them. We'll just take the bits out that show sprite 1 and just show sprite 0. So the beauty of this is we can choose video 2, we copy this. Okay, we won't copy the sprite data because that's going to be different, and we will paste this into video 4. Okay, so we've got our import sources there with our constants and vic2 constants, which is good. Our program's going to start at hex 1000, which is fine. It's going to put some basic in that will run the program automatically. So let's have a look. We load 200 into sprite pointer 0, which 200 is this address here, so we're going to point sprite 0 at this address when we put the sprite data in, and 201 for sprite pointer 1. Well, we don't want sprite pointer 1 because we're only going to enable one sprite, so we can just highlight that and delete it. These are the colours. We aren't using multicolours and we're only using one sprite, so we just need these two here, and we will get rid of the rest of it. We'll change that to yellow because he's PacMan. Okay, this is positioning him on the screen. We put his X position at 44. We don't want to do that with sprite 1, we just want to do it with sprite 0. And 120 into coordinate Y. So we want to delete sprite 1 because we're only using sprite 0. High res sprite there's no coloured sprite, so 0 value is high res, so all 8 sprites here are going to be high res, so we only want to care about this one, which is 0, which means it'd be high res. If it was a multicolour sprite we would do that, but it isn't for this one, so we'll keep that at 0. Double size, I suppose, yeah, for this example we could make him double width and double height. We don't need it for sprite 0 and 1, so we will change this one here like that. So we're only setting sprite 1 to double X and double Y. This turns the sprites on, so again it's turning on sprite 0 and 1, so we will change that. And then this is setting the border colours. So now all we need to do is put our sprite data in and see what happens. Copy from the file saved from Sprite Mate. Paste it into here. Okay, ignore this stuff in comments is auto generated. So we've got sprite 0 right, 0, 1 and 2, and left is 0, 1 and 2. So let's save this file, let's run it. And there we have it. So this is our sprite on the screen. He's not moving or doing anything. We've literally just turned him on. So how do we get him to move? The first thing we want to do is have it move in a raster interrupt. So we need to put a raster interrupt into our code. And we're going to do the same as what we did on video 3, where we trigger an interrupt when the raster line hits 0 at the top of the screen. And it will do that on PAL 50 times a second. So, without typing it all in from scratch, we will go to video 3. And here's our IRQ init. And we'll just go through that in a second and make sure it will be suitable for video 4. So we'll put this in here. And what we will then do is we'll change our basic upstart to, instead of starting from here at start, it will start from here at IRQ init. So let's look at this IRQ code again for a second. So what we're doing is disabling interrupts while we do this. This bit of code here will disable CIA interrupts, and this bit of code here will enable Raster interrupts. So now we'll get an interrupt whenever the raster line hits what's in these two registers. Okay, and the reason it's two registers is because the raster lines are a 16-bit number because it's bigger than 255. I think it's 320 roughly. But we want this to run at raster line 0. So what we do here, this bit of code here sets this bit to 0 of this address, which is the most significant byte of the raster line number, which is the bit that's greater than 255. So we set that to 0, and then we set this to 0 here, which is the least significant part of the number, or the byte of the number, which is the bit between 0 and 255. So we're setting this to 0. So with this set to 0 on here, this bit set to 0 on here, that means the interrupt will happen at raster line 0. So what do we want to do when the interrupt happens? We want to go to the code that runs in IRQ, which we've not written yet. And what we do there, as we explained in the previous video, we set the 16-bit address for the IRQ code into these memory addresses here, whoops, and here again it's 16-bit number, so we need it in 2 parts. So what happens is every time a raster line hits 0, it will then run this code here, which we haven't defined yet. So once we've set this up, we then re-enable interrupts again. So now the thing is to write our code for IRQ1, which will happen 50 times a second when the raster bar hits 0. So I think we should just put it into here. What I will do is I will copy it from video 3 again, because why not? So here's IRQ1, and we'll take out what we don't need and we'll paste it into here. So let's work out what this is doing and take out what we don't need. Now if we remember, IRQ1 then set the raster bar interrupt to a different number and then set the code for IRQ to run. We don't want to do any of that. So the first thing we're going to do is play music, or change the border colours, or do anything with the sprites. In fact, what I'm going to do is delete all the code that's in here, okay, and just leave this bit here for our code to run to do with the sprites. And then obviously once it's done that, we had a little routine called ACK, which acknowledges the interrupt with the registers and sets it up for the next interrupt. So let's go back and copy that here. There's ACK. Okay, I believe we've got everything we need for the interrupt. It's not going to do anything. It's going to push the accumulator, the X and the Y register to the stack. Then it's going to go to ACK. Okay, and then when it hits ACK, it will acknowledge the interrupt here. Then pull the accumulator, X register and Y register from the stack, and then jump to this routine here, which handles the rest of the interrupts like joystick, keyboard, etc, etc, etc. So we've set our interrupt now. It doesn't do anything, but we can run the program anyway. We'll save it and run it, and it should do nothing, which is good. So the interrupts are there, we can still do that. The sprite is displayed on the screen, but it's not doing anything. So now we can write the code that actually does the sprite animation. So I'm going to put that in a separate part of the code here. We'll call it Sprite 0 animation. And what I will do here, we'll start our code here, and on this thing we will, when our IRQ code runs, instead of putting the code in here, I will get it to jump to the subroutine. And then, so it'll run what's ever in here, and then I'll get it to return back to here. So we'll keep our code nice and clean and separate. So this would be the code that we want to actually animate our sprite. Now, so how do we animate our sprite? Well, it's quite straightforward. We just change the sprite pointer to the next frame. So, as you know, the sprite pointer is pointed to 200, and 200 lots of 64 bytes makes 12800. So 200 will point to this sprite. If we set the sprite pointer to 201, sprite 0 will display this sprite, and 202 this sprite, etc, etc, etc. So what we need to do is we need a piece of memory that will have the animation frames in them. So the way I'm going to do that is I'm going to do another memory address here, sprite 0 animation frames. Okay, let's do the numbers. So at this point in memory, it's just going to store some 8-bit numbers, and we will use those numbers as the animation frames for the sprite pointing right. So it starts off at 200 with his mouth shut. Then 201, he starts to open it. 202, he then opens it fully wide. Then he starts to close it with 201. So if this cycled the ball, it'll be shut, shut, open, zoom in a bit, shut, half open, fully open, half open, shut, half open, fully open, half open. So we can get it to keep repeating these. So we now want some code that will cycle through these. Once it gets to the fourth one, it will then reset back to the first one. However, with everything else, the count starts at 0, so it'll be 0, 1, 2, 3, 0, 1, 2, 3. So every interrupt, we want to change the sprite pointer to a new one of these. So that's all done behind the scenes with the interrupt code, not in our game code. Now how are we going to do that? The way I propose to do this, let's come out of the zoom, is to have another piece of memory. It's 1 byte of memory. And what this will do, this will have a frame counter. BR0 underscore frame underscore counter. So at this address there'll be 1 byte of memory, and it will have the counter by byte. So at the moment it will be 0. So this will have our number, which will be 0, 1, 2, 3, 0, 1, 2, 3. So this will tell our code which frame to use, the 0th frame, the 1 frame, 2 frame, 3 frame. So all we want to do is increase this each time. Once it gets greater than 3, we want to reset it back to 0, so it carries on the cycle. So let's put that into code now. So the first thing we want to do, because we're going to use this as an offset, we will use the X register. So we will load into the X register the value that's in this byte here. So that'll be SPR0 frame counter. So this value here is loaded into the X register. If I could just zoom in a bit here. Okay, I'll repeat that again. The way we're going to do this, we're going to load into the X register the value that's in this byte here, which tells us which one of these to actually display. We're going to compare it. This is the bit of code where we check that it's not greater than 3. So we will compare it because 3, 0, 1, 2, 3. We don't want it to be 4. So the way we'll do that is we'll compare it to the number 4. If it's not equal, to 4, i.e. it's 1, 2 or 3, we want it to branch to another part of the code. Let's call that our continue code. Oh, that looks terrible. Okay, we haven't defined that, so we'll define that here. So this is the bit of code that will run if the frame counter number is 0, 1, 2 or 3. If it's greater than that, we want to do this. We want to reset it to 0. So we want to load the value 0 into the X register, and then we want to store that value, store the X register in the frame counter. So let's go through that again. We load the frame counter here into the X register. We compare it with the number 4, which means it'd be too big. If it is not 4, it's less than 4, okay, or not 4, so it'd be 0, 1, 2 or 3, then we will miss off this bit of code and just go from continue. If it is 4, we reset it to 0 and store it in the frame counter byte as 0. So what do we do if it's 0, 1, 2 or 3? We will load into the accumulator the byte from here. Okay, so we load this, the byte from here, which would be this one. But we're going to use a trick here. So we load the value that's in here, which is 200. But then we put the comma X on there as well, which means the value we're loading the bit of memory that is here with an offset of this. So if this is 0, it will load this one. If it's 1, it will load this one. If it's 2, this one. And if it's 3, it'll be this one. If it's 4, it will be reset beforehand back to 0, so it will load this one again. If you see what I mean? So this is how our cycle works. So we will load the value 200, 201, 202, 201 again into the accumulator, and we will store that in the sprite pointer address memory, which is down here. So if X is 0, it will store 200 in the sprite pointer address, which is 200 is sprite 0. So that will set the sprite to whatever frame we want, either frame 0, 1 or 2 or back to 1 again. And it will do this every time, but we're still not quite cycling, are we? Because there's nothing that is stopping that from being 0 there, so it's going to just do 200 all the time. So every run we need to increase this by 1 until it gets to 4, and then it's set back to 0 again. So we do that with one command here. We do inc. So that will add 1 to this address here. So let's go through the logic of how this would be. First Raster Interrupt happens. Okay, it will call this program here. It will load the frame counter, which is 0. Compare it with 4. Is it 4? No. So go to continue. It will load the value in here, which is sprite anim frames, comma x, which is 0 at the moment, which is 200, and then store that in the sprite pointer. So the sprite pointer for 0 will point at the sprite address 200, which is sprite 0 here. So that will change the sprite to frame 0. Then it will increase this memory address here by 1, which is our frame counter, and then it is 1. We complete the raster interrupt with a RTS there, so that will return us back to here, and then it will finish the raster interrupt. Okay, then we get the next one a 50th of a second later. This is now 1 because we've changed it. It will hit this here. It will load what's in the frame counter, which is 1. Compare it with 4. Is it 4? No, it's not. We will carry on. Load sprite anim frames, comma x, and because x is 1, it will load this number here and set that in the sprite pointer address. So the sprite pointer will now point at frame 1. Then it will increase this address to 2 and then go back to the interrupt, finish it off. And that will continue again for the next frame, and it will set this to 3. And then on the last one, when it does frame 3, the last thing it does is increase this to 4. Okay, so when the following interrupt happens, it goes back to here. It loads the frame counter. It is 4, so there's no fourth sprite frame. We've got to go 0, 1, 2, 3. So it is 4. It sets it back to 0. So this becomes 0 here. Stores that in the frame counter, and then loads sprite anim frame with an offset of x, which is now 0 again, which resets it back to here. So this is how our cycle works. Shall we have a look at this and see what happens? Let's save it and hit run. And here we have a PacMan who is moving very, very, very quickly with his mouth. He's got something seriously wrong with him, or he's been on some ridiculous drugs. Class A ones, I'd imagine. Okay, so what we want to do is we want to slow this down, don't we? We want it to move at a realistic pace. So what's the good way to do that? The way I would do this is, let's just close this off here. So this code runs and it cycles through every raster interrupt, which is 50 times a second on a PAL machine, 60 for a NTSC. I think maybe doing it every interrupt could, is a bit much. So why don't we do it every, say, 6 interrupts? So it'll do it 50 divided by 6 times a second, whatever that is. So I don't need to know, I'm just plucking the numbers out of my head. So how do we do that? Okay, well, we don't want to write any code in here that does nothing for a period of time and then carries on with the interrupt, because that will affect the whole timing of everything. We want the interrupts to run 50 times a second. So what we want to do is have the sprite animation code here only run every 6th interrupt. So the first interrupt will just run the normal interrupt code. So the second, third, fourth, fifth, and then on the 6th one, it will then run this sprite animation code. So how are we going to do that? The answer is another byte of memory, and we'll have a delay counter in. So let's put that in here. SPR 0 animation delay counter. Okay, so this is just, remember this is a label, so we're going to do another byte of 0 in there. So it'll be one memory address that will have a delay counter in it. We'll set that to 0. So how do we want to work this? Okay, so what we want to do is that's at 0. Every time it gets to 6, if that's 0, okay, do not run this code, and then increase it by 1, and when it gets to 6, run this code, and then reset this back to 0. So let's look at how we're going to do that. So we'll go back to the top of our code here. First thing we do is we'll increase that counter by 1. So every raster interrupt, it will increase the counter by 1. We will then load that into the accumulator. And then compare it with the value of 6. If it's not 6, so if it's 0 to 5, we want to do nothing. So we'll do branch if not equal to 6, do nothing. Or actually, let's SPR naught no action. So I don't want it to run anything like this if this is not 6. So we'll do, just before we come out of our sprite code, we'll put another label in here. No action. So let's take another look at this closely. Our interrupt runs, okay, it jumps into this sprite animation every interrupt. Okay, so what it will do, it will increase this delay counter, which is set to 0. Then it will compare the delay counter, load it into the accumulator and compare it to 6. If it is not 6, okay, then it will branch to this label here, which will then return us back to the interrupt code, which is from here. So when we do a JSR, when we do an RTS, it returns us to the next code there. So it will acknowledge the interrupt. So it will have done nothing except increase this delay counter. However, so on the 6th raster interrupt, this will be 6. It will compare it with 6. BNE will not happen because it's equal to 6. So it'll ignore this, and then it will carry on and do our sprite here. Shall we save that and have a look? Okay, so something's wrong here, and I think I would know exactly what it is. It's not moving at all, or it's moving very slowly. I'll show you what the problem is here. What we need to do is, once it hits 6, we need to reset this back to 0 again. Otherwise we have to wait until it gets to 255 and then back to 0. So it won't be doing it every 6 at all. So let's load the accumulator with the value of 0. and we will store that in Sprite animation delay counter. So once it hits 6, it will reset it to 0 and then run the code. Let's try that. See, we've got to have these mistakes in here, so we learn from them. That's better. See, now look, that's PacMan sort of opening and shutting his gob at a reasonable rate now. So now we've got that. Obviously that's running in the interrupt. See, I can do anything else I like here. Look at my program listing. And this is just running in the interrupt code. So the next thing we want to do, we want to look at changing his direction. Okay, so all that's doing is him facing right. Okay, so what do we think would be a good way to do that? Well, I think, and this is the way I would implement it, where we have these animation frames here, okay, these ones are for him facing right. So if we put a comment in here called right, okay, that'd be our default. Okay, we also want a set of frames for him facing left, and if we had up and down, we would have those as well. So if he's facing left, the cycle would be, let's see, the highest number here is 202, so it would be 203, which would be this right here, and then we've got the other two beneath that. So I'd say it'd be 203, 204, 205 and 204 again. Okay, so all that it means is these 2 bytes will be shifted down in memory or up in memory because we've got extra bytes there. I mean, we don't have to worry about the address like in the old days. It will not affect this at all. But what we need to do is actually work out how we're going to tell it to run these and not these, or the other way around. We want it to run, if he's facing left, we want it to run these and not these. So the way I'm going to do this is, see this offset here is between the numbers 0 and 3. So 0, 1, 2, 3. Because this carries on next in the memory, this number is 4, 5, 6, 7. So if he's facing left, if we added 4 to this offset, it would run these. If we didn't add 4 to it, it would run these. If you see what I mean? Because this is continuing in the 64's memory. You've got 200, 201, 202, 201, 203, all sequentially in the memory with nothing in between them. So adding 4 to this will point it at these here. So how are we going to implement this? Well, the first thing we do is, yet again, we need a bit of memory to hold the information of what direction the sprite is facing, and what better number to use than the offset. What I would do is I'm going to put this at the beginning of the code, right at the start, the very first part of the code, 1000. The reason I'm going to do that will be clear in a minute. So I'm going to put a byte of memory here, which is sprite 0, or the SPR 0 direction. And this will hold just a byte of memory, and we will have it at 0 for the start. And if it's 0, that means he'll be facing right, because this will be the offset. If he's facing left, this will be 4. And we will be adding this here to the offset. Okay, so let's look about how we're going to do that. So it's going to be in this part of the code here. because this is working out what the X register is in regards to the animation frames. This bit of code here actually loads the correct value from here and then sets the sprite pointer. So this is the place where we want to add 4 if he's facing left or 0 if he's staying right. So the way we'll do that, we'll clear the carry. So you'll see. We do that whenever we're going to do an addition. The number we want is in the X register. And we can't do a lot of addition and subtraction in the X register, so a little trick we're going to do here is, let's say we're on number 2, okay, so this would be 0, 1, 2 or 3, so say we're on number 2. We will transfer the value of X register into the accumulator. We'll use the ADC, which is add with carry, and the carry is 0. So that's standard practice. If you're doing 8-bit addition, you clear the carry first. We will add with carry the value of the accumulator, which is what the X register is, with the direction, which will be 0 or 4, depending whether he's going right or left. Let's zoom in on this a bit. So that will give us, if this was 2, that will give us 2 if the direction is 0, right. If the direction is left, it will have 4 in there, so it will make this 6. 1, 0, 1, 2, 3, 4, 5, 6. So I'd play this one. So we've added, the accumulator now contains the value we want to go into the X register, which is no good because we're using the X register further down. So what we need to do, now we've done that, we need to transfer the accumulator back into the X register. So if this was 2 before and he's facing left, this would now be 6. If he's facing right, it would still remain as 2 because it would have copied into the accumulator, added the value of 0, transferred the accumulator back to the X register, and that is what we'll be using. Sounds complicated. It isn't as complicated as you think. So I'll show you the reason why I've done this at the beginning of the program at memory address 1000. Let's run the program. Okay, so that value is 0, as you can see here, so he's right. Let's change that value to 4. So all we do is poke the decimal of 1000 hex, which is 4096. Okay, we will poke that with the value of 4. And there we go. He is now facing left and chomping away. And as you can see, it's not affected any of the game code itself because it's running in our interrupt. We can change it back to 0 anytime. And now it'll be facing right again. So the reason I've done it this way is when you write a routine in your game that checks for a joystick input, if the register detects that the joystick is facing right, then all you would do is change that direction by here to 4. If he's facing right, it will put 0 into this byte. If he's facing left, it'll put 4 in. Then it could put 8 in for up and 12 in for down, or any other things you like. So the game logic will just have to change this in order for the sprite to actually change direction. In fact, I think we've got time. We could write some game logic, very, very simple, quick, just based on keys. So we've got no game code here, so let's write our game code underneath start and before the RTS here. So first of all, let's zoom in a bit here. we'll put our game code in underneath here and just jump to it. So we'll call it game code. RTS here. So what would happen is this will just JSR to game code. This is our main program here. Once it's set the borders, set the interrupts up, it will jump to game code, and then when game code is run, it will return back to basic. All our game code does is return back to basic. Let's get it to wait for a key to be pressed. So we'll put another direction label in here. Normally we'd put some code in between these two to initialize things, but I've got nothing to initialize at the moment. So all we're going to do is jump to this kernel routine, which checks for a key to be pressed. We'll compare the key to run stop, which I know is hex 113, well 103, sorry. If it's not 103, go back and check for another key press. So this is a very simple, this is our game code here. For now, all it's going to do is wait for a key press. If it's run stop, then quit the game code, which will take it back to here, which will then quit back to basic. If run stop isn't being pressed, it will just carry on waiting and just looping around this loop. So let's give that a try. There's our sprite. We'll hit all keys, nothing happens. We'll hit run stop and it breaks. So what I'd like to do is change this so that if we hit the L key, he faces left, and if we hit the R key, he faces right. So how are we going to implement that? Very, very straightforward. Let's imagine our address here at the top. This here is our direction byte, so it has either 0 or 4 in it, okay? So imagine what that looks like. If it's 0, it looks like this in binary. If it's 4, it looks like that. So all we need to do is turn this bit on or off depending on what the key's pressed. That's how binary works, and that's how it's quite simple. So I'll change this first of all to branch if the run stop key is hit to a label called quit. And after that, so I've changed my loop slightly here. So if it is run stop, it will go to here, which will then return us back to our routine and go back to basic. If it's not, it will continue to this one where it'll go back to key loop. So let's just test that. It is all fine. That's fine. So we run it again, we hit any other key, that's fine. So let's compare it with L, which I believe is 4C. I will double check that. If that's right, we'll create one called left. And then what we'll do, we will just load 4. I won't do the bit flipping for now. We'll just store that in the we'll store that in the direction. Actually, we'll want to put this, yeah. Then jump back here because we don't want it to quit. We don't want it to carry on an RTS. We want it to go right back here. Let's do run it. Or let's just check that first. Actually, save that. There we go. We hit L and he changes direction. So let's put the same in for right. So we'll copy this, paste it in here. And all the code for right will do. As you say, left puts 4 in the direction, right puts 0 in the direction, and then goes back to looking for a key. We just need a comparison here. Okay, and we'll just change this to the hex value of R, which I believe is 5.2. Let's run that. So he's facing right. Oh, I hit R and he went and faced left. So I think something's wrong here. Let's debug this and find out what's going on. Of course. If it's R, it needs to jump to right, not to left. That's me copying and pasting, and not actually finishing the job off. So if the L key is pressed, it jumps to this routine here, left, and then goes back to here. If the right key is pressed, or the R key is pressed here, it jumps to the right routine, which then changes the direction back to right, and then jumps back to the key loop, which will keep running until run stop is pressed. Let's save that. There he is, he's facing right. Let's hit L, and he's facing left. Let's hit right, or R, and he's facing right again. Perfect. Hit run stop, and we're back into basic. So we can't, if we hit L and R now, that doesn't do anything because the routines to detect for the L and R key are not in the interrupts, they are in the game code. The interrupts just process the animation. So I think that comes to the end of this, so let's just have a very quick recap of what we've learnt. So what we've done is we've drawn some animations frames in sprites. We've got six frames here, 3 facing right, 3 facing left. We've created a Raster Interrupt that happens when it's a raster line 0, which is 50 times a second. What that interrupt does, change the sprite frame every 6 interrupts, so it counts down every 6 interrupts, and it cycles through the 4 different frame states. Even though there's 3 images, it's 4 because it's closed, half open, fully open, half open again. So it cycles through those 4 every 6 raster interrupts, because we've got that in there to keep it at a realistic speed. And then what it's also doing is it's changing the pointer to another set of animation frames for when he's pointing right, or pointing left, sorry. So it's adding an offset to that of 4, so it'll run the frames for pointing left. And it does all this while not executing very much game code at all. All the game code is doing is waiting for an input and then changing 1 byte of memory, which will then tell the interrupts which set of sprite frames to use. So I think that concludes the video. Again, leave your questions in the comments. I'll try to answer what I can. I hope you enjoyed this, and the next video I imagine we will start using sprite movement with maybe joystick, and we'll maybe even make a start on sprite collisions as well, seeing how we go. So that's what we'll be doing next. So until then, I will see you on the next video.